Hi, I'm George Woodbury from College of the Sequoias in Visalia, California, and in this video we're going to learn how to solve equations that are quadratic in form, meaning I like to call them quadratic in hiding. We don't know that they're quadratic, but they look like they fit a quadratic pattern. Let me write that down. Quadratic in form. And the way that we're going to solve these is a technique called u-substitution. We're going to put in a new variable, u, which is going to turn the equation into a quadratic equation. We're going to solve this equation for u, and then we're going to reverse the substitution so we can get back to our original variable. I've got 4 examples teed up here, one of the basic 4 flavors that you might see. So here, what we're really looking for, there are 2 terms that have variable parts to them. X minus 4 to the 2/3, x minus 4 to the 1/3. What we need to find is the middle term, the one that if you square it, you'll get the other term. And here, that's the x minus 4 to the 1/3 power. So I'm going to let u equal x minus 4 to the 1/3 power. Then that also tells me that u squared will be x minus 4 to the 2/3 power. So every place I see x minus 4 to the 1/3, I can replace that with u. Everywhere I see x minus 4 to the 2/3, I can replace that with u squared. So this equation becomes u squared minus 5u minus 24 equals 0. A nice, clean, simple quadratic equation. This is one that we can solve by factoring. U minus 8 times u plus 3 equals 0. If you don't see the factoring, you could use quadratic formula. It will take you a lot longer though. And my 2 solutions here are u equals 8 and u equals -3. However, I need to know what x is equal to. And so here I can replace u by x minus 4 to the 1/3 and solve this new equation involving the rational exponents. So the 2 equations I'm going to work with are x minus 4 to the 1/3 power equals 8 and x minus 4 to the 1/3 power equals -3. To solve each equation, I'm going to raise both sides to the 3rd power because 1/3 times 3 is 1. That clears the variable term from its exponent. Like that. On the left-hand side, that just leaves me with x minus 4. On the right-hand side, I've got 8 to the 3rd power, which equals 512. And then I can add 4 to both sides to get my first solution, which is 516. Now, because the denominator in the exponent was a 3, we can take the 3rd root of negative numbers as well as positive. I don't really need to check for extraneous roots here. I'll do the same thing for the second equation. I'm going to raise both sides to the 3rd power. That leaves me with x minus 4 equals -3 to the 3rd power is a negative times a negative times a negative. 3 negatives, that makes a negative product. That's going to be -27. I'm going to add 4 to both sides, and I get x equals -23. And again, as I mentioned, a negative solution here, -23 minus 4 being negative, is not a problem because the 3rd root of a negative number is something that we can do. So these 2 solutions are valid. Let me write them in ascending order. -23, comma, 516. Right. Right. That's one where we had a 1/3 power and a 2/3 power. In this example, I've got one exponent that's -1, one that's -2. If I let u equal x to the -1 power, then I know that u squared is x to the -2 power. And I can rewrite this as 15u squared plus 13u plus 2 equals 0. Now this one might not be that easy for you to factor. So I'm going to solve it with a quadratic equation with you first, and then I'm going to come back and show you the factored form. So I'm going to work a little bit lower because I'm going to erase this in a minute, but u would be negative 13 plus or minus square root 13 squared minus 4 times 15 times 2, all over 2 times 15. U would be negative 13 plus or minus square root 13 squared is 169. Minus 4 times 15 times 2, that's 120. All over 30. 169 minus 120 is 49, and we know the square root of 49 is 7. So we end up with negative 13 plus or minus 7 over 30. Negative 13 plus 7 over 30 is negative 6 over 30, or negative 1/5. And negative 13 minus 7 over 30 is negative 20 over 30, or negative 2/3. So our two solutions are going to end up being negative 1/5 and negative 2/3. However, I'm going to show you how to get there by factoring. So let me get rid of this first. And let's go back to factoring. This one factors to be 5x plus 1 times 3x, I'm sorry, not x, 5u plus 1 times 3u plus 2. 5u times 3u is the 15u squared, the 1 times the 2 is the 2. But notice 1 times 3u is 3u, 5u times 2 is 10u, 3 and 10 make 13. So my two solutions come from 5u being negative 1, or u being negative 1/5, and 3u being negative 2, or u being negative 2/3. Now, once that's done, I have to reverse the substitution. I have to come back and put in x to the negative 1 power for u. So x to the negative 1 power equals negative 1/5, and x to the negative 1 power equals negative 2/3. There's a few ways we can solve it. Probably the cleanest way is to realize that x to the negative 1 power, that's 1 over x to the positive 1 power. It's the reciprocal function. So if we know that 1 over x equals negative 1/5, to find the solution, we take the reciprocal of both sides. X will be negative 5. If 1 over x equals negative 2/3, the reciprocal x would be negative 3/2. And by the way, here, because we had u being basically 1 over x, the only solution that would have been no good would have been x equals 0, which we didn't get. So again, in the first one, we took a look at u equals x to the 1/3 power. Here, we used x to the negative 1 power. The third example, we're going to let u be x squared, that middle variable term, x squared. If we square it, we get to x4. That tells us what we want to use for u. Let u equal x squared, then u squared will be x to the 4th power. And we've got u squared plus 5u minus 36 equals 0. This one factors. Typically, the ones that you're going to get that are quadratic in form, they're going to be factorable anyway. So definitely try to look for that if you can. This factors to be u plus 9 times u minus 4 equals 0. That gives us u equals negative 9, or u equals positive 4. Now I need to unsubstitute, reverse the substitution. So I originally replaced x squared by u. Now I'm going to replace u by x squared. X squared equals negative 9, or x squared equals 4. And when we have x squared, the way that we solve that, to get rid of that square, we're going to take the square root of both sides. But remember that when we take the square root of both sides, we have to do plus or minus the square root of that constant side. So the square root of x squared equals plus or minus the square root of -9. The square root of x squared equals plus or minus the square root of 4. And now we just need to take the square root of those two numbers. The square root of -9, because it's negative, we know that we get I in the solution, and the square root of 9 is 3. So we get x equals plus or minus 3i. And for the other branch of solutions, the square root of 4 is 2, so we get x equals plus or minus 2. If we were to write all four of these in the solution set, it would be -3i, 3i, -2, and +2. When you make the reverse substitution, now you have to think about, okay, how do I get this to become x? I had x to the 1/3 power before. I had to raise it to the third. This time I had x to the second power. The way you get rid of a square is with a square root. One last one, and this is similar to a radical equation that we solved before, but when it's in this form where you have x, square root of x, and a constant term, it's going to be easier to solve using a u-substitution. Let me show you why really quickly. If we got the radical, if we isolated the radical, what we would have is the square root of x equals 40 minus x over 6. And then when we would have to square both sides, and that right-hand side is going to get a little funny looking to us. So I'm going to show you a different way to do that when it's in this form. Oops. That seems to be my move. Cut. Perfect. Let x, let u equal the square root of x, then u squared will equal x. Raising the square root to the second power just gives you x. So here I've got u squared plus 6u minus 40 equals 0. That factors to be u plus 10 times u minus 4 equals 0. So either u equals -10 or u equals +4. Reverse the substitution. Square root x equals -10. Square root x equals +4. Now the first solution, -10, is actually a problem for us because a square root cannot equal a negative number. We can take the square root of a negative number, as we did in the last example, and get an imaginary number. But a square root can never be equal to a negative number. Right? That's defined to be the principal square root, which is positive. So this one has no solution. If you solved it, you would get a solution of 100, and if you plugged it back into the original equation, it won't work. To solve the other one, we will square both sides, and we get x equals 16. If you substitute that one back in, that will work. So the solution set contains the number 16. All right, we took a look at 4 different quadratic in form scenarios that you may see. Let me write this down here. We had x to the 2/3 and x to the 1/3. We had x to the -2 and x to the -1. We had x to the 4th and x squared. And then finally, in this example, we had x and square root of x, or really x to the 1/2 power. What we notice is that this was the group that we let u be, because if we multiply its exponent by 2, we got the part in front. So that was our u-substitution. That gives us an easier equation to solve at first, and then we reverse the substitution to find our solutions for x. All right, that's it for this section. In the next batch of videos, we'll move on to the next one.